Vanakkam students. Let's we begins with same chapter 1, laws of motion. I hope you understood the previous class concept. So what we have discussed in the previous class: force, motion, inertia, types of inertia, linear momentum. I think you understood the same concept. Let me see what we are going to discuss in this class. See what are the learning objectives are given in this module. Let me see that. Newton's laws of motion, Newton's first law, force, types of forces, resultant force, rotating effect of force, moment of the force, application of torque, principle of moments. See, 9 topics are given. It's a very simple topic. See, in this class only we have to learn the definition of the given topics. So very simple, easiest topic, just you understand the different causes of motion. Let's we start with Newton's laws of motion. First law, Newton's first law, other name called as inertia. What's the definition for Newton's first law is: every body continues to be in its state of rest or the state of uniform motion along a straight line unless it is acted upon by some external forces. Already we discussed in the inertia topic. See, when an object is moving or if it is rest, it will be continuous in its same state. When we are not giving any external forces, it will be continuing the same state. Maybe it is in rest or in uniform motion. So that is explained by Newton's first law. So once again I repeat the definition: every body continues to be in its state of rest or state of uniform motion along a straight line unless it is acted upon by some external forces. Force. See, force already we discussed in the previous classes. Force means push or pull. When we give push or pull on an object, that is force. It's an external force. When we give any push or pull in an object means what will happen? So let me see. Produce or tries to produce the motion of a static body. If we give any force on an object means if it is in rest, it will produce or tries to produce the motion. It will move from one place to another when we give force on an object. Next, when we give a force in a moving object means what will happen? It tries to stop a moving object. If the object is moving, when we give any force means it will tries to stop that moving object. Next, when we give a force to a moving object means it will change the direction of the motion of a moving object. So these all happens when we give force in an object. So if we give force in an object means it will change the direction and it will produce the motion. Otherwise it will stop the moving object. So we called force is a vector quantity because it has both magnitude and direction. So let me see the next topic. Types of forces. See, types of forces means based on the direction of force, the forces can be classified into two types. One is like parallel forces, another one is unlike parallel forces. So like parallel forces means, see, two or more forces equal or unequal acting along the same direction. If two or more forces of equal or unequal forces, if we are giving any object means in the same direction, then we called it as a like parallel forces. So already I told you these type of forces only based on direction. Based on direction only forces can be classified into two, like parallel forces and unlike parallel forces. The two parallel forces similar only single word will be changed. Like parallel force means same direction. Unlike parallel force means opposite direction. Let me see. Unlike parallel forces, the same definition, two or more equal forces or unequal forces act along opposite direction parallel to each other, then we call it as an unlike parallel forces. See, the best example is tug of war. See, we give the parallel forces, but it is not equal, maybe equal or unequal forces, but it is in the opposite direction. So that is the best example of unlike parallel forces. And what's the next topic is a resultant force. A resultant force, before we are going to learn in this resultant force, just we have to know a resultant. See, when several forces, lot of forces acting simultaneously on the same body, same object, the combined effect of the forces termed as resultant force. So one or more forces acting in the same body, same object, we called it as a resultant force. The resultant forces also a vector quantity, because in this force already we know that force is a vector quantity because the force contains both the magnitude and direction. Let me discuss the resultant force. See, resultant force consists of two types. One is balanced forces, another one is unbalanced forces. Balanced forces means if the resultant force acting on a body is equal to 0, then the body will be in equilibrium. All the forces, resultant means more than one forces acting on a body, if it is equal to 0, just you look at the picture, opposite, see, when we are giving more forces but it does not move, body is in equilibrium, the same state only, same position, equal position only, no changes, no movements, so that force is called as balanced force. Resultant force is always equal to 0. And the next topic, unbalanced forces. What is the meaning of unbalanced forces? A resultant force is not equal to 0. Then causes the motion of the body due to unbalanced forces. What is the meaning for that? See, from this picture, if you see one side, one person is standing to pull that rope, another one, two persons is standing and pull the rope. So folds they are giving, but unequal forces. So we understand that resultant force is obviously not equal to 0. So if the unequal forces are given, means it will cause the change of motion. It will cause the change of motion. So we call it as an unbalanced forces. So these are the two types of resultant force. Let me see the action of forces. Let me see the action of forces. What we have discussed in this action of forces is, when we give more than one forces, what is the answer of resultant force? First, see in that tabular column, we have to discuss first column action of forces, next one diagram representation, third one what is the resultant forces of that action of forces. See, already we discussed the like parallel forces. Parallel forces are acting in the same direction. So diagram, if you see F1 and F2 are the two forces acting in the same direction, then what is the resultant force? That is add sum of the two forces. That is the resultant force. Next action of forces is, if that forces we are given in that opposite direction, means what is the resultant force? Which force is greater, we have to subtract from that value. If F1 is give more force, means we have to subtract F1 minus F2. If we give more forces in F2, then that resultant force is F2 minus F1. So resultant force is depends upon the greater force. The third action of force is parallel equal force are acting in opposite direction in the same line of action, because F1 is equal to F2, opposite direction but equal force. So net of see resultant force is 0 because equal force. See, see, already we have seen in the balanced forces, if we give the equal forces, then the body is in equilibrium, the resultant force is 0. So these are all the action of forces. Rotating effect of force. So I have given two pictures just to see that picture. First one is, just one person is opened the door. Our next picture is, one person is unwinding the screw or winding the screw. See what you have observed from this picture. So have you observed the position of the handle in a door? So where the handle is placed? See, have you tried to push a door by placing your hand closer to the hinges or fixed edge? What do you observe? If you try to push a door by placing your hand closer to the hinges, means it's very difficult to open. If you try to push a door by placing your hand, see, by pushing the handle, means it is very easy to open. So what do you observe from these pictures? See, door can easily opened or closed when you apply the force far away from the hinges. Then only it will easily to open or close the door. So this turning effect of the applied force is called a rotating effect of force. You just see the distance between the applied force and the hinges. If it is more, means the application of force is also more. So what are the terms related in these rotating effective force? Let me discuss. The door can be easily opened or closed when you apply the force at a point far away from the fixed edge. Fixed edge is nothing but that is hinges. So you just to understand, when we apply the force at a point far away from the hinges means the door can be easily opened or closed. Next, this turning effect of the applied force is more when the distance between the hinges or fixed edge and the point of application of force is more. Point of application is nothing but that handle of the door. The distance between these two, the force is more. So what are the terms related to this rotating effect of force? The axis of the fixed edge, that is the hinges about which door is rotated, is called axis of rotation. When we apply the force on the handle of the door, the axis of the hinges, the door is rotated. You just imagine, when we push or pull the door, the hinges will be rotated. That is called axis of rotation. And the next picture we have seen that unwinding a screw. See, fix one end of the rod to the any needle or screw. Somewhere you have to keep it. Apply a force at the other end. The rod will be turned about the fixed point, is called point of rotation. So these are all the terms we have discussed in this rotating effect of force. Moment of force or torque. See, moment of force is nothing but the rotating or turning effect of force at a fixed point. That is called moment of force. Means the turning effect of the force acting on a fixed point is called moment of force, is also called torque. See, what is the definition of moment of force is, it is measured by the product of force and perpendicular distance between the fixed point or fixed axis and the line of action of forces. So it's nothing but is a product of force and perpendicular distance between the fixed point, where we have to give the rotating effect, that fixed point, and the line of action of forces. We called it as a moment of force. So torque, that symbol torque is equal to force into perpendicular distance, that is d, perpendicular distance between the fixed point and the line of action of force. Torque is also a vector quantity and the SI unit is Newton meter. So what is the next topic? That is couple and moment of couple. Couple and moment of a couple. Couple means two equal and unlike parallel forces applied simultaneously at two distinct points constitute couple. See, what is the meaning? Two equal and unequal parallel forces applied simultaneously in two different points. So we called it as a couple. See, in the given picture, opening a tap, a churning of curd, steering wheel of a car, if you see, means two different types of two equal and unlike parallel forces we have to give simultaneously. Then what will happen? It will see, we called it as a couple. So all these couple, it will shows the rotatory motion. So rotating effect of a couple is known as moment of a couple. So let me see moment of a couple. Moment of a couple. So rotating effect of a couple is known as moment of a couple. So what is the definition of moment of a couple? Is measured by the product of any one of the forces. Couple means two forces, so any one of the forces and perpendicular distance between the line of action of two forces. So nothing but is a force to rotate the body in which it is applied. That is moment of a force. So moment of a couple is equal to force into perpendicular distance between the line of action of forces. M is equal to F into S, and the SI unit of couple is moment of couple is Newton meter. CGS system, its unit is dyne centimeter. So the next topic is application of torque. Let me see a few examples with explanation. Application of torque. See, torque is nothing but a rotating or turning effect of a force at a fixed point is called torque. So where we have to apply this type of rotating effect of force or turning effect of a force. First example is gear. So gear is a circular wheel with teeth around its rim. See, it helps to change the speed of rotation of a wheel by changing the torque. That means the rotating effect at a fixed point helps to transmit power. So gear is the applications of torque or a rotating effect of a force at a point. And the next example is seesaw. So seesaw, most of you have played on the seesaw. There is a difference in the weight of person sitting on both sides. The heavier person lift the lighter person, we know that. So when the heavier person come closer to the pivot point, that center of position, means the distance of line of action of forces is decreases. The rotating effect is less in that. Less amount of rotating effect or torque is act on it. So that lighter person can able to lift the heavier person. So that is the application of torque in seesaw. And the next example is steering wheel. Steering wheel means is a car easily transferring the torque to wheels with less effort. When we give less force to transfer the wheel, if the distance of the monocle is high, means we have to give the less effort. So these are all the application of torque. So let me see the next topic, that is principle of moments. Principle of moments. See, like or unlike parallel force act on a body is in equilibrium. The body is in equilibrium, we called it as a principle of moments. What is the definition of principle of moments? Is algebraic sum of moments in the clockwise direction is equal to the algebraic sum of the moments in the anti-clockwise direction. See from that diagram, F1 is a force produces an anti-clockwise rotation at the distance d1, and the force F2 produces a clockwise rotation at the distance d2 from the point. So what is the formula? Moment in the clockwise direction is equal to moment in the anti-clockwise direction. F1 into d1 is equal to F2 into d2. So these are all the concepts we have discussed in this module. Once again, we have to remember what you have learned in this module. First one, Newton's first law, like parallel forces, unlike parallel forces, balanced forces, unbalanced forces, moment of force or torque, couple, moment of a couple, and principle of moments. So these are all the terms we have discussed in this model. So what are the questions arises from this model is Newton's first law of motion, like and unlike parallel forces, balanced and unbalanced forces, moment of force, moment of a couple, principle of moments, and one more creative question, why a spanner with a long handle is preferred to tighten screws in heavy vehicles. So first four question is a book interior question, remaining three is a book back question. So my dear students, read well. Thank you.